Hey, hey. So we're going to look at our last video. It's going to have to do with complete and net ionic equations, okay? So I'm going to go ahead and share my screen. Trying. Oh, I hate it when it does this. There we go. Okay. There you go. That's something that I have there prepared for. Okay. We're going to look at complete and net ionic equations. So let's start here with some notes, okay? All right, so complete and net ionic equations. These particularly relate to reactions that occur in solution. Okay, so what that means is when you have one solution and you mix it with another solution, you know, what reactions might occur. So there would be a reaction that occurred in solution, right? The complete shows all species as they actually exist. I'll explain that. And the net ionic shows only the reaction that occurs and omits something called spectator ions. All right? What is a spectator ion? A spectator ion does not participate in the reaction. All right? And you'll see what I'm saying, I think. Okay? This will be easy for those if you understand how to do a balanced double replacement reaction. Okay? It does now matter that you look at the state of matter present, whether it's a solid, liquid, or gas. So the first thing we need to discuss is the dissociation or ionization of dissolved ionic compounds, which are called salts, right? Okay, so if I take sodium chloride and it's a solid and I put it into water, yeah, we know salt dissolves, right? It dissolves. But when it dissolves, it separates into its ions. So I actually have the sodium ion floating around in the solution and the chloride ion floating around in the solution. So this is called a dissociation equation. Okay, it shows how salt dissolves. When I put this salt in water, I do not have NaCl. Rather, I have sodium ions and chloride ions. Cool. All right, let's look at another one. Let's say that it's not sodium chloride, but it's sodium sulfide. Ionic compound salt. It dissolves in water. I now have 2 sodium ions because of this 2 here, right? It dissociates to make 2. They have a +1 charge. And I have 1 sulfide ion with his 2 negative charge floating around in the solution, right? So if I was to look at a particulate level drawing, a drawing that shows the actual particles, I would have 2 Na sodium ions floating around for every 1 sulfide ion. Hopefully that makes sense to you, okay? When we go to do these equations, we will dissociate. Dissociate is what you just did. Dissociate is to separate into ions. Dissolved ionic substances only. And strong acids, but we're not going to deal with that. Okay, so let's give an example. Let's have P, or let's just go like this, lead 2 nitrate, which is aqueous, reacts with sodium chloride, which is also aqueous, and we have learned that it's going to produce lead 2 chloride. All right, and that, I'm telling you, will be a solid. It will precipitate out, and we will then also have what? Sodium nitrate, and the sodium nitrate will remain dissolved. So I'll give it an aqueous in the solution. Let's write this into a balanced chemical equation, all right? And I'm going to make the assumption that you have learned how to do this, so that's not going to be the focus of what I'm doing here, all right? Lead 2 nitrate, PbNO3 2, aqueous, plus sodium chloride, NaCl, aqueous, yields lead 2 chloride, PbCl2, solid. Okay, I told you that, and that's important now. And sodium nitrate, NaNO3, aqueous. All right, I see I've got 2 nitrates and 2 chlorides, so I need to put a 2 here and 2 here. That's my balanced chemical equation. I am now going to write my complete ionic, and I'm going to do that by dissociating all aqueous salts. Remember, salt's just an ionic compound. So I'm going to take my lead, oops, I don't need to go from there. Let me go like this, sorry. I'm going to take my lead 2 nitrate. I'm going to dissociate it into the lead 2 plus ion. And notice there will be 2 nitrate ions. Those ions are floating around in the solution, right? That's what's floating around. This compound is also aqueous, so I will dissociate it into the 2 sodium ions and the 2 chloride ions, okay? Because it's dissolved, so it's dissociated. The next compound, notice it is a solid. Therefore, it is not dissolved, and I will not dissociate it. I will not dissociate solids, I will not dissociate liquids, and I will not dissociate gases. To be aqueous means to be dissociated, to be dissolved, okay? So I will literally, oops, let's get rid of the highlighter. I will literally keep that as is, solid, and then I will look at my two sodium nitrates. I will see that it's aqueous. I will dissolve it into the 2 sodium ions that are now in the solution and the 2 nitrate ions that are now in the solution. You have to put the charges, all the little charges, in an ionic equation. Ions and atoms are different properties. What we have here is our complete ionic, okay? It shows everything as it actually exists in solution. All we did was dissociate anything that was dissolved and kept together our solid. Now let's cancel our spectator ions. Cancel anything that's the same on both sides of the reaction, okay? So I see that I have 2 nitrate ions here, and I have 2 nitrate ions here. So those are going to cancel. Like right here, I have a lead ion. I don't have any lead ions over here. I do have 2 sodium ions right here, and 2 sodium ions right here though. Here I have 2 chlorides. I do not have any chlorides. So what I'm left with is my lead 2 ion, who is in the solution, my 2 chloride ions, who are in the solution, came together and formed, listen to my words, they 2 ions in the solution, they found each other and they formed an insoluble salt, a salt that does not dissolve, therefore it is solid. They came together to form the insoluble salt, lead 2 chloride. And that's what we see floating around the solution. Everything else is just hanging around. Did not participate. They are spectators. Okay, let's do one more together. All right, Let's go H2SO4 plus NaOH, aqueous, yields H and OH. We're going to get H2O. I'll just write liquid or 2O this time. And we're going to get what? Sodium sulfate, right? That will be aqueous. Okay, let's make sure it's balanced. No, I'm going to need a 2 right here and a 2 right here. Okay. All right. Let's get the complete ionic. That will be 2H plus ions plus the 1 sulfate ion plus the 2 sodium ions, right? Plus the 2 hydroxide ions, right? Yields, now look here, this is water. It is not dissolved. We will keep it together. And this is dissociated. We've got the 2 sodium ions for every 1 sulfate ion, and those are floating around in the solution. Okay? So that's your complete ionic. Let's cross out our spectator ions. It looks like we've got a sulfate over here. Looks like we have 2 sodiums over here. It looks like we're left with 2 hydrogen ions. Sorry, that's messy. Found the 2 hydroxide ions. And oh, if you just don't know this, hydrogen and hydroxide love to come together to make water, right? So we just formed water. Those of you that were asking, this is your neutralization reaction. This is your acid. This is your base. It formed water and a soluble salt. So this was the actual reaction that occurred in the solution, is the formation of water. Okay? Solids, liquids, or gases, you do not separate. I'm going to leave that at that. I'm going to ask that you maybe do a couple practice problems. I will post them for you. It'll just be a couple. All right. Thank you, guys. I'm going to stop share, and I'll see you later. How do I do that?